So this is the neck assembly. This is really important to get right. This is what holds the entire weight of the rider and all the components and batteries. So there's a lot of forces going through this neck. You should have already printed off the neck piece, this cylindrical neck piece, and then slotted it on to the tube. You want about 30 millimeters on the end left there, but it's dependable. If you're going to use rubber buffers, you want a little bit less. I have my scooter tilted up slightly, so I use about 28 millimeters on the end and 3 metal washers as well. So this should just slot on if the rest of the frame has been assembled correctly with the correct critical width. See, I'm just slotting it on and looking for the holes. You can look through from one end to the other. Once you can see from one end to the other each hole, you'll be able to slot in the 8mm threaded bolts. You should have pre-cut these to the correct lengths as shown in the drawings, and you can push them through. If they're a bit stubborn, you could use a drill to grasp the end of it and drill it the rest of the way through. But it's imperative that these go in correctly in the right place, so your drilling positions on the other steel, on the other aluminium, sorry, need to be as accurate as possible. All of the measurements are to the millimeter, are rounded to the millimeter, the nearest millimeter, so the drawn dimensions are as accurate as you'll get with drilling it with a 1mm pilot drill bit and then drilling it out to with the 8mm drill bit. So I'm just putting one in, putting the washer on, because everything needs washers because it's aluminium and it's quite thin. So there has to be a washer on each. It shows on the drawings which washer you need for each. On this one I actually forgot one of the washers, but I took it back off and put it on later on after the video. The threaded rods should be tight against the aluminium tube as well. If you put everything in as accurate as possible, you want as much tension and compression as possible in all of these components. So all 4 rods need to be tight up against the tube, and the aluminium square sections, the 4 pieces, they need to be tight up against the plastic neck piece. This is me just drilling it in because I couldn't get it through. If you have to drill it a bit, it's fine. Don't drill the hole out, just drill the bolt through. Just grip the end of the bolt with a drill piece and then just drill it, just send it through. You want tightness on every piece, so you want all 4 to be tight against the aluminium cylinder, and you also want the aluminium cylinder to be tight within the printed neck piece. and then you want the printed neck piece to be as tight as possible within the 4 aluminium square sections. Everything nice and tight, don't over tighten it though, and this way you'll have a stable neck or stable steering column. You don't want it to be turning. After this I'll show you how to put the 3mm threaded rods in. These are important because they effectively hold up the entire weight of the rider, but all the tension that's in this assembly could actually do that anyway, so it's possible to do it without the rods, but you need the rods just in case. It's a real pain to do, but just take your time. Get them in, get them tight. And remember, you want roughly 30mm on that end there, from the plastic part to the end of the cylinder. This is me just tightening some of the pieces up now. Tighten these ones up first so that it's pushing in to the neck, and then tighten the other ones up last. As I said, the critical dimensions for the frame assembly all need to be exact to the millimeter. If the frame's in correctly, then everything else just goes into place easily. You'll know if the frame's incorrect because you'll go to put the under tray on and it'll not fit correctly. So as long as you get that inside dimension correct, I can't remember what it is, but it's shown on the drawings. Here's me just using a spanner and then the grips on the other side, so you got a grip the threaded rod to stop it spinning, and then tighten it up. Try and get it so that you've got the same amount of extra rod sticking out on each side as well. You don't want to have a centimetre sticking out on one and it being too short on the other. Get it so that they're the same. You want just very minimal sticking out on each side. There are caps that cover these bolts that you print off. I've designed them in 3 different depths to take into account any that are sticking out a little bit, but you really want to get them as close as possible. This is me just gripping the end and turning it. And note as well, you want to grip the end when the nut is on it. Don't grip it without the nut on it, because the end of the thread will be damaged. It's okay to damage it when the nut's on it because you can unwind the nut and it corrects the thread, but you really don't want to just, grind the thread off, because then your nut's not going to go on. These are nylock, flanged, and they've also got a serrated bit on the end as well, which is completely over the score. You don't really need, the maximum cost nuts, but I thought I'd just get the flanged ones just because there's a lot of force going into these. Here's the one that I forgot to put the washer on. So when you're doing it, pay attention, don't do what I did and forget, because I had to take it back off and put the washer back on after. But yeah, I would go for a nylock nut, just to reduce the chances of it coming off when you're riding, because you don't want, this is quite a fast scooter, you don't want to have a failure of any sort when you're riding it. And with the flanged, it spreads the load as well onto the washer. So you got the load spread onto the washer, and then the load spread again onto the aluminium square section. So I did this and then had to go back and undo it because I didn't pay attention. And just tighten them one at a time, get it so it's just touching, and then go on to the next one, and then just keep going around them, tighten them a little bit more and a little bit more, and tighten them from both sides as well. So grip one side, tighten one, and if you've got the thread coming too much through, wind it back, get it through so the thread's just right, and then hopefully there'll be enough grip through it so that you don't need to use the pliers on it. You can just use the spanner to tighten the last bit. It's like this, getting all of them the same, everything the same. And don't over tighten them either. You don't want to bend the square section in. You want it nice and tight, not over the score. I've probably over tightened that one as well, to be honest. And now this is what happens if you don't pay attention. You have to go back, put the washer on. My other side's in the right length and it's in correctly. Just in with that washer. That's the neck. Done. Now we need to put the suspension wires on. They run through the top. So this is the bottom. So this goes down. This is what rides on top of the wheel assembly. I've put washers on that to reduce wear, but I'll show you that when we come to it. This is the top piece. Now this is quite important. This is what takes the entire weight of the rider and everything, but it's helped with all the forces that you just put through the neck assembly itself. But it's still really important. I've ridden it without the suspension wires, but and there's also a small fail safe as well on the bottom of the tube, where it meets the front wheel. The assembly there has a piece sticking up, so even if it did collapse, it would only collapse onto that, so it wouldn't cause an accident. But still, you don't want it to drop down that, 10 or 20 millimeters onto the wheel. You might not even notice if you're riding, but you want it to be suspended. So this is the top part that holds the suspension wires to have So the whole thing's getting held up on this piece, which is why it's very tight. It's very thick. It needs to be printed at 100% infill, and the wires need to be run through this and made quite reasonably tight as well, and both equally tight. So this is me just hammering the top piece on. It's difficult. You can, if it's being real trouble, you can gently heat it, and that will help to get it on. But you can use pliers to sort of go to grip it and twist it. I'm battering the hell out of it to try and get it in. Don't be tempted to use any lubricant to get this thing onto the top. You need it to be tight, and you need it to not turn. So if you batter it on, get it as straight as you can, and then you can use pliers to just turn it that little bit to line the holes up with the holes that are in the neck piece, the barrel shaped piece at the bottom. So that's both pieces on. Now here's the wire. It's a 3mm threaded rod. The sizes and specifications are in the drawings. There's two of these. What I do is I put it into the bottom, put it in the end of the drill, and then I run it all the way through. It is tight. It is only 3mm that I've used for the holes that it runs through, again, to give as much, to make it as tight as possible, to make it grip the inside of the plastic. So I just run it up, taking my time easily. I recommend you wear safety eyewear for any of this, but especially this, because the wire can actually spin round quite violently if it goes out of control. So I put it in as far as I can get, and then I've got to take the pain and use pliers to send it up through the last little bit. Also beware, because the rod will get hot as it's going through the plastic. So it's reaching up to get to the top piece. Now I have to disconnect. So two of these have to go the rest of the way, but the one on the inside, you hang the controller off of it, so you don't want to put the inside one up all the way, because the controller's got to get slid down on that part there. As I'm showing you, these need to go up the way. I'll only do that at the front, for the front one at the moment. See how I'm having to turn it manually with this? It takes ages and it's a pain. So that's me taking it all the way to the top and then put the nut onto the top. There's a small washer that you need for the nut on both the bottom and the top as well. Wrench it all the way right through, and there's me sliding the controller down on it. This holds the controller. This means there's no need for any plastic grips for the controller because they're all different sizes. So when you've got it hooked on there, the casing for the controller goes over the top. That's me just showing you the casing goes over the top. There's various sizes of these. Hopefully I'll have posted one size for each. The small one, this is a very small type. There's a larger type that I use